We live on a planet composed of diverse landforms, distinct climates, and unique people and cultures. Every continent, every country, every village holds its own history, its own mysteries. But at the heart of each of these diverse lands lies something in common that has shaped the past, affects the present, and will mold the future. That something is geography. Geography is more than places on a map. It's global connections and incredible creatures. It's people and cultures, economics and politics, and it's essential to understanding our interconnected world. And yet, maps are still one of the most essential tools that people use to understand geography, the environment, and the constant changes of our planet and its inhabitants. There are political maps showing territorial boundaries, maps of soil type, weather patterns, elevation data, and almost anything that comes to mind. Today, maps are no longer static. They are alive and changing and bringing geography to life. Technologies such as Geographic Information Systems, or GIS, has made this possible. Let's discover how GIS works by exploring the fascinating lands of Asia and the many layers of its cultures, features, and people. GIS reveals the power of geography by providing digital tools to visualize what exists, to gather and interpret tremendous amounts of information in order to model what has happened in the past and predict what may happen in the future. Asia is important in many ways. It is the largest continent, encompassing nearly 50 million kilometers of land area, nearly 30% of all the land on Earth. It is a land of extremes, boasting the highest point and the world's tallest land-based mountain, towering to 8,848 meters or 29,028 feet above sea level. Asia is home to 10 of the 10 highest peaks in the world. At the other extreme, the Dead Sea, at 409 meters or roughly 1,300 feet below sea level, is the lowest point in Asia and the world. With GIS, not only can we visualize these peaks and valleys, but we can quickly show additional information on the fly and in 3D. Explorers can study the slope of the land, the trails of Mount Everest, and even study weather patterns to plan potential expeditions. Why do climbers favor the Southeast Ridge Trek starting in the south in Nepal, while others choose the Northeast Ridge route beginning in Tibet? GIS can reveal various political and cultural factors, physical and environmental conditions, as well as weather phenomena, to help paint a picture that can answer these kinds of questions. Asia is recognized not only for its large mountain peaks, but also for its large and rapidly growing population. 9 of the top 20 most populated countries are located in Asia, as illustrated by these hotspots. Nearly 3.9 billion of the Earth's 6.6 billion people live in Asia. Using this 3D view of population density, we can see how the population is most concentrated in cities and urban settings. Why do some areas contain extreme population density? A closer look at Mumbai and Kolkata in India will help us understand. This area is home to hundreds of millions of people, and between them is the Ganges River Valley. This population density map shows high population numbers in red and areas with fewer people in gray. History and GIS can show us how and why both Mumbai and Kolkata became large cities. Their close proximity to rivers and the coast allowed them to become strong seaports. They became large cities that could support heavy trade, create transportation routes inland, and provide jobs for its inhabitants. crops tend to grow well in fertile valleys where rivers run, and the Ganges is a huge river in a warm climate. This creates the ideal soil conditions allowing agriculture to thrive, which in turn leads to population growth. And a third factor called the monsoon brings rain to India from June to October. The rainy season is very important to the millions of people who live in southern and eastern Asia. The monsoons are crucial in sustaining the agriculture and the people of India. And in other parts of Asia, too much water proved to be devastating. In 2004, Asia was affected by the Indian Ocean earthquake and tsunami. Using GIS to model the path of a tsunami wave can help communities create evacuation and emergency plans and ultimately save lives. GIS has been an invaluable tool that can be used to assess damages and help communities in their recovery and rebuilding efforts, whether from a tsunami, hurricane, or fire. Whether it's too much or too little, water is an essential element for our survival. The Yangtze River in China is the longest in Asia and the third longest in the world, providing water to rice-growing regions in the south of China. Here, too, managing fresh water has become a crucial issue. China has built the Three Gorges Dam on the Yangtze River for flood control and hydroelectricity. It is one of the largest hydroelectric power stations in the world. The dam will flood the river valley behind it, displacing over 1 million people. A GIS analytic model of future water levels shows us what the lake behind the dam will look like. Scientists have predicted the loss of many valuable archaeological and cultural sites, as well as effects on the environment. Again, GIS can be used to model the environmental impact and help scientists to find solutions to minimize man's impact. For China, the benefit of harnessing the river's power and eliminating the devastating seasonal flooding along the Yangtze River outweighs the historical and ecological loss. The industrial cities along the river will increase in size as people migrate from the countryside to the cities. Asian cities are among the largest in the world and will become even bigger in years to come. By 2030, experts predict that 2/3 of the people in Asia will live in megacities, cities with more than 10 million people. What problems will arise as cities vie for clean water, clean air, and other resources? Housing, employment, land use planning, transportation, and public health are just a few issues. For instance, in 2007, the avian flu shook the medical community and health organizations around the world. The avian flu is transmitted from bird to human and causes severe illness in humans who are infected. Since the speed and distance of modern travel is so great, GIS analysis can be used to track known cases to help scientists set up quarantine sites around the world. Though not escalating to the level of a pandemic, the deadly implications drew attention that the avian flu was not a problem for Asia alone, but for the world. We are not alone. We share the same problems and discoveries with our neighbors down the block and on the other side of the world. We are connected by geography, and we must see the interconnection in order to understand the relationships and patterns and the effects of our decisions.